getting assignment is difficult. So I will ask you in the group, you have to write some code.
Sir, you're not audible.
Muted.
Sir, excuse me, sir.
Sir, you are
Sir,
muted.
you are
sir.
muted. You are muted.
Okay, so those students, those are doing laboratory, possibly you are writing some code. Okay, so what was the first code it was asked in the laboratory? Can you tell me?
Sir, to
Okay.
find the BS.
Okay, all right, but I am giving a series of code. So whatever you have learned, because they are method only. This first one, find the optimum solution of the linear programming problem using basic feasible solution method. Okay, so summary is like that, because when we are having a system, we find the basic feasible solution. Basic feasible means all these solution should be non-negative. So after finding the basic feasible solution, as you know, each of the basic feasible solutions are the extreme points. Okay, this maximum or minimum occurs only extreme point only. Okay, so depends on the basic feasible solution. We are checking which one is maximum, which one is minimum. And sometimes if the basic feasible solution number is huge, this method is becoming tedious. So we use simplex method. But whenever you are testing, you test with a smaller problem, maybe 5-6 variables, not more than that. Okay, so that you cannot check. So first one is about the maximization type problem. Second one is the minimization type problem. You see, the constants are all equally type. So already after slack, surplus, artificial variables, when we add, so this is becoming equation. No need of again add some extra variables. Okay, it is already given equation. Okay, you start finding solution, basic feasible solution, and search for minimum and maximum. The first problem. Second problem. So this is type 1 inequations are there. Write a code, use simplex method for the maximization type problem. Okay. Number 2. Number 3, maximization and minimization. Actually, it is one problem. So the constants are all equally type, or less than equal type, or greater than equal type. All types are there. All type. So artificial variables you have to use. Once artificial variables are using either big M method or 2-phase simplex method. Number 3 about the big M method. And similarly, number 4 about the 2-phase simplex method. Okay, both are there. Then number 5. Number 5 we have not discussed in the class. We will discuss about the duality theory. With respect to the dual problem, we have dual simplex method. Number 5. So we'll start. You can write code up to number 4. Okay, now. Okay. Then number 6. Number 6 you have completed. Actually, it should be first 5, then 6. About the revised simplex method. In the revised simplex method, 2 parts are there. One is product form of inverse. Another is revised simplex method. It is audible? Okay. So 5 and 6 you can interchange. So but keep it as it is. So first you write code for 6, then for 5. Okay. Means so 5 problem already ready. Okay. Then 7th one about the integer programming. Okay. We will discuss 2 methods. One is the Gomery cutting plane method. Another is branch and bound. Okay. So you will write code for the Gomery cutting plane. But branch and bound methods are little tedious, so you will not be able to. So number 7 we'll discuss. Then 8 is about the transportation problem. We'll discuss. 9 is about the assignment problem. Okay. And the 10 is about the game theory. Okay. So very clearly everything is mentioned. So if you are writing code in the laboratory, then extra benefit you are getting. but I want this code in this format. And most likely I'm interested for Python, C++, but don't borrow from the net. You write yourself because you have to explain me. And when we explain, there are several test examples are with me. I will give a text example, you solve. If your program is not giving correct answer, over. Okay. So no question of revision. You do all the experiment. So I have given. So latest by 31st March, you have to submit. And by 31st March, I will complete the syllabus. Okay. And you know, the first week of April, second week of April, test and all these things will. Okay. So I will take interview also. Interview in the sense, group interview. Okay. And when you write code, the code should be written in groups. So in a group, there will be 5 students. 5 students. Okay. 5 students. Today I will formulate the group. Okay. So accordingly you get ready. Okay. So and you tell me who will be the group leader. See your roll number. And if you are not coming to the class, then you will suffer and you will not blame me. Many you are not coming and I am unable to keep track who is coming, who is not coming. See this course, I will tell you, 400 students applied for this. Okay. Only I have selected around 150 students are from mathematics. Okay. So little more than 100, maybe 110 or 15, and 50 students are from mathematics. Okay. So the CGPA around 8.5. I have put a cutoff because if I will put 8, then there will be 250 students or 350. I cannot control. Okay, you cannot take the interview or make the group this that. It will be difficult. So that is the reason I have put some restriction 8.5. Even many teacher has requested me you include these students, that students. I have not bothered about that. Okay, so see I am telling the computer science students. From the computer science, nearly 20 students are there. I don't know why they are interested for the operation research. So I am sure they are very much interested to write code. Okay. See, the code will help because how much you have learned and how much OR you have learned. So your code will reflect. Okay. So please prepare accordingly and you submit. So roll. See here. Are you able to see the roll list? Are you able to see the roll list?
Yes, sir.
1, 2, 3, 4, 5. Okay. Adarsh Goyal, Akshat Sharma, Nitin Patel, B. Parik, Gauri. Okay. Out of these 5 students, anybody there? Anybody? Hello? Are you able to see? So if nobody there, you see, I'm marking all absent. And the group leader is serial number 5. Serial number 5 means Gauri. Gauri is the group leader. Okay. Then because I have to make group. So in a group, maximum 5 students are there. At the end, if there are 3 or 4 or 6, so I will include in one group. Okay. So it depends on the whether it is multiple of 5 or not. Okay. So then we from the 6th, you can see here 6, 7, serial number 6, 7, 8, 9, 10. Okay. Serial number 6 is Nikita. 7, Ishita Agarwal. 8, Bhavesh Jain. 9, Pradimna Bansal. 10, Anmol. Anybody there?
Yes, sir.
Who is there?
Sir, Nikita.
Nikita is there. Okay. So see, as per the serial number, so Anmol Munje will be the leader. But since he's not there, Nikita is there. I am making the group leader. Okay. From the Anmol or Nikita. Okay. Nikita is present. Okay. Right. Then 11, 12, 11, 12, 11, 12, 13, 14, 15. 11 is Brajesh Chandra Jha. 12, Saish Sanay. Then Shivashish Das. 14th, Apurva Rai. And 15th is Shivashish Maurya. Anybody there?
Yes, sir.
Who is there?
Sir, Saish Shanoy.
Eh?
Sir,
Yes, yes.
sir, Apurva.
Apurva.
Yes, sir.
And serial number 15. See, out of 5 students, only one is there. See, I'm telling.
Sir,
Tell me who is there. I'm taking your attendance. Okay.
sir, serial number 12.
Serial number
12.
12 is present. If when I'm calling your roll number, if you are present, tell me yes. Okay. So
Sir, serial
number
10 was
15.
also present.
So group leader is serial number 15 or 14? Apurva. Who is Apurva is there? No.
Sir, I'm present. Apurva.
Apurva. So you will be the group leader. Okay. So 14 or 15. So you are present. Okay. The person who is present, so he will be the group leader. Okay. So then 16, 17, 18, 19, 20. Shivam Rajesh Gupta, Soumyadeep Nandi, Azad Jitendra, Akita Jajo, Ayush Prasad. Anybody there? Anybody there?
Yes, sir.
Yes.
Yes.
Yes, sir. Present.
Your name, please.
Akshita, sir.
Akita. 19. Okay. 19 is the 19 is present. You will be the group leader. Okay.
Sir,
And
I'm
if
also
somebody, somebody is not writing, not doing anything, okay. So I will, the email ID also I will share. Okay. So you can inform me. So I will take action. Okay. Then 21 onward. Adhiraj Rastogi, Aditya Singla, Lakshmi Chajar, Shailesh Soni, Shashank Singh. Who is there?
Sir, Shashank Singh present.
Okay, you are present. 25, you are the group leader.
Thank you.
23 also present.
23, your name? Okay, 23 is present.
hello. 20 is also present, sir.
20, okay,
Previous
20 is also present. Okay. See, whoever is, you have the leading capacity. Okay, you can cooperate. You can interact with other students. Then you can do everything. Okay, so you should. Okay, if somebody is not helping, not coming, so if somebody is not coming regularly to the class, he cannot be the group leader. And if you see, for example, in a group there are 5 students. Okay, 5 students I'm telling. So you will tell me who is the topper, who has contributed most. Okay. So accordingly, okay, if suppose 2 are there, then I will, if these 2, then I will take interview of these 2. Okay. So you will decide, tell me who is the best, who is better, because the your CGPA most likely very similar. Okay. Why I am telling you will realize later. Okay. Then 26, Simiran Rajagopalan. 27,
Yes,
Sumit
sir.
Kumar Agarwal. 28,
Present,
Tushar
sir.
Prabir Verma. 29, Bital Agarwal. 30,
29
Priyanshu
Vital
Pandey.
Agarwal
Who is
present.
there?
Sir, 29 present.
29 present. 30,
Sir, present.
29 present, 30 present. These 2 only. Okay.
27 also present.
27 is present. Okay. So I'm making Priyanshu Pandey is the group leader.
Okay, sir.
Okay. Because it will be easier for me to search the serial. Okay, serial wise. Okay. And this
Yes.
roll list also I will pass to everybody. The roll list. Okay. 31, 32, 33, 34, 35. 31 Aman. 32 Tanish. Ishani, 33, Nanda Kuti, Siharsa, 34, Naresh Kumar, 35, Utsav Pal.
Sir, 35.
35. Anybody else present? Anybody else present? See, how can you, spare a class without attending? How can you see, you are showing interest as if, you are in the only subject you want to learn, but you are not coming to the class. So this is the situation. Okay. So 36, 37, 38, 39, 40.
Sir, 36, Tushar is present.
Tushar Kumar Mishra, Piyush Kumar.
Sir, 38,
Alak
Alak
Dikshit,
Dikshit present.
okay. Abranil Das, Nirmal. Who is there? Tell me. 36 is there.
Sir,
Tushar Kumar Mishra.
36, Tushar. Yes,
Sir,
sir.
38.
36 is there.
Sir, 38 is also there.
31 is Aman. Aman is there. Okay, sorry. 36 is there. Tushar Kumar Mishra is there. Okay.
Sir, 38.
38 is there. Okay. Then
Alak.
40 is there. Abranil Das is there. 40 is there. Nirmal Kumar. Nirmal is your. No. Alak is your. Okay. Alak is the 38. No. 38 is the
Yes,
group
sir.
leader. Okay. 41. 42, 43, 44, 45.
43, sir. Present.
41, Swasat. 42, Ishita. Ishita is there.
Yes, sir.
You see, chemistry, how it will be useful in your subject, how will be useful?
Sir, not exactly in chemistry, but in other subjects it's useful.
Are you interested to do some course like, the management or maybe some other type related management? Are you interested or the chemistry?
Yes, sir. Yes, sir.
Okay.
No, sir. I'm
Ishita,
interested in non-course.
43 is Ayush Mishra, 44 Sachin Agarwal, 45 Urbi. Okay. Who is the group leader? Urbi there? Urbi is not there. Okay. So Ishita, 42 is all right?
Yes, sir.
You are strong in programming?
Yes, sir.
All are strong. Okay. So you should spend time because you are getting so much free time. (46) Harsh Kumar. 47 Akshat Sharma. 48
Yes, sir.
Akshat Sharma is there.
Yes, sir.
Okay. 48 Tushar. Tushar.
Yes, sir.
Okay.
Yes, sir.
49 Aditya Tiwari. 50 Akash Agarwal. 50 Akash Agarwal is there? Or Tushar? Tushar is all right. You will be the group leader.
Okay, sir.
So last time you took my subject optimization technique.
Yes, sir.
You left in between.
Yes, sir.
Without learning OR, you joined the optimization technique. Why?
I could not cope up with the.
First you will study 5th year, then 4th year.
Yeah, I said I didn't complete it then. So I submitted the codes and after that I left.
Surprise, you see, first, you should learn about the UG subject, then PG subject. Okay. So 51 Amar Datta, 52 Anil Kumar Jogi, 53 Arya, 54 Aishik Das, 55 Aish Dak. 55 is there. Who is there?
52 is there.
52 Anil Kumar Jogi.
Sir, 54 Aishik Das.
54 is also there. 55 is not there. So you will be the group leader, right? 54. Then 56 Ayush, 57 Venkat, 58 Chitesh Bansal, 59 Piyush Sunil, 60 Deepraj Brahma. Who is there?
56.
58.
56.
58 is there.
56.
And who else?
56.
56 is there. So
59.
59 is there. So 60 is not there. So group leader is 59. Is it all right, Sunil?
Yes, sir.
Okay. '61, '62, '63, '64, '65. '61 is Deepanshu Singh.
Yes, sir. I'm here.
Devjit Chaudhary, 63 Yogesh, 64 Gaurav Jain, 65 Gautam Singla.
65 is there.
64 is
65 is there. Okay.
63 is
the
there,
group leader. And nobody else is there.
Sir, 61 is there. 61. 61.
62. And who else?
64.
61. 60?
64.
Gaurav is there.
Yes, sir.
Okay.
63 also, sir.
Sir, 61
63 also there.
Yes, sir.
Yogesh, okay. This is the only group all are present. Okay. 66, 67, 68, 69, 70.
Sir, 70 is there, Kritika Bagadia.
Okay. So Jaspreet Singh, Jaya Kedia, Karan Upal, Krishna Nayak, Kritika Agaria. 70 is the group leader. Okay.
Sir, 68 is also here.
68 is there. And who else? Anybody? Anybody? '71, '72, '73, '74, '75. Dilip, Manda Dilip, Manushani, Vaishnavi.
Sir, I'm here, sir. 72 is here.
Okay. Venkat, Rahul Reddy.
Sir,
74 is here, sir.
Rahul Reddy there?
Yes, sir.
Okay.
74
And who
also.
else? Who else?
74.
74. Venkat. And who else? Anybody? '76 Nishant Goyal, 77 Pradyumna, 78 Manoj Kumar, 79 Maheshwari,
78 present, sir.
80 Patel Silas. Who is there?
Sir, 76 is there.
70?
76.
76 is there. So Patel,
78, sir.
Patel is there? Patel? 80? Not there, okay. Then 76. Nishant Goyal. You will be the leader. Right?
Yes, sir.
Okay. So that 80% you can tell him. So suppose say somebody is not willing or he is not, you are not coming to the class, how can you be leader? Okay. And once, see, this carries minimum 10, maximum 15. You see, why actually we add all the component, whatever the test mark you are getting. Okay. That is 30, 30, 30, 90. Okay. This 10 mark, what? Attendance, because you are not coming. So assignment is that. Okay. What I am asking? 10 mark. And this 5 mark. 5 mark is with me. Reason is I want to round up to your grade. Okay. For example, you are getting 85 plus. 85 plus. So I will not leave it as it is. Okay. 5 mark more. So mean you are getting around 15 mark. Okay. You can say that. So if you are performing well, then so your score will be good. If you are not performing well, even you may get out of 10 also 0, 2, 3, 4, 5. Okay. So you have to, you see there are 10 codes. For each code, you can see around 1 mark, 1 or 2 mark. Okay. Depends on. So you need, see, when you submit a code, your code size should be small. See, the code which can be written in 100 line, you are making 1000 line. Okay. So it is not acceptable. So like that, because this course should be capable of solving all the problem. All the problem according to your desire, not my desire. Okay. So how much? So I have to test it whether it is fitting or not. Okay. So you plan it accordingly because you have enough time, 2 months. So 81, Sai, Praful ready. 82, Prakash. 83,
Yes, sir.
Prabhakar. 84, Pratibha Biswal. 85, Rahul Saini.
Sir, 83 present, sir.
82 also,
Prabhakar.
sir.
83 is Prabhakar. 85, Rahul Saini. Pratibha Biswal.
82, sir.
85 is there or not? Rahul. 85.
82 is present, sir.
85. So you will be the group leader. Okay.
82, sir. Sorry, sir. 82.
82. Prakash, no?
Yes, sir.
See, this is one-way attendance. Periodically, I will just call you randomly your number. Okay? Randomly your number. If you are not there, gone. Okay? So, for example, this week I am calling you. Next week I may not call you. I can call somebody because you see, 180 students. If I am calling, then I will lose 20 minutes. Okay? So today I am calling because many are not coming, and I have to assign some work. Okay? That is the reason I am calling.
81
so,
also, sir.
Okay. 86.
67 also.
3 there.
Present, I was
87, Ratnesh. 88, Rishabh Agarwal. 89, Rishit Singhania. 90, Rohit Deshpande. Rohit is there? Rohit Deshpande?
86 present, sir.
Rohit is there or not?
Sir,
Okay. I'm calling again.
90 is present. 90 is present.
3 there.
Yes, sir.
Ratnesh. Rishabh. Rishit.
Yes, sir.
See, during class hour, what you are doing if you are not attending class? Okay.
So 90 is there.
90, Rohit Deshpande. I have made the group leader, so you are present. Okay.
Sir, 67 is also there. I wrote in chat.
Your roll number is? Your roll is?
67.
See, the train has moved to the next stoppage. Okay. So
Sir,
how
I
you expect that I should come back and then it is not
I
fair.
wrote in chat at that time only.
No, it is not fair. I'm telling. No.
So I wrote in
67,
chat when you.
Joy Acadia. 67, Joy Acadia, no?
Sir, 79. Sir, 79 is also
Okay,
present.
just at the end of the class, you tell. Okay. So in the beginning, I will take the attendance. Let us say if somebody is really presenting. Okay. So many times I am finding you just attend and just move. Okay. So these 2 pages I have completed. Then another 2 pages. Okay, there. Okay. Sachin Kumar Chaudhary, Shagnik Sahana, Sakhit Divedi, Sakhik Kabra. So many Sakhik. Then Sudhanshu Ranjan. Sudhanshu Ranjan is there? Sudhanshu Ranjan? Anybody from this group?
Sir, 94 present.
Sakhi, you will be the group leader. Okay. 94.
Sir, 97 present.
Okay. 96, 97, 98, 99, 100, 96, Krishna Kumar. 97, Rudra.
Sir, 97, yes, sir.
Tamanna Chaya. 99, Tanatati, Arun Teja. 100, Vans Shud. Who is there?
Sir, 96.
Sir, 97.
97.
96. Sir.
Rudra. 100 is there?
Yes, sir.
100. Shud is there? Shud. Are you able to see? 100 is Shud. So 97 is the group leader.
Sir, 96 also there, sir.
Yes, your number is?
96.
Krishna Kumar.
Yes, sir.
When I'm calling, at least you tell yes, sir. 101, 102, 103, 104, 105. 101, Manoj. 102, Vishal.
Present, sir.
Vishal is present.
The 101 is also
103,
present.
Yash Agarwal. 104,
Present, sir.
Karthik Reddy. Yash Agarwal present. Karthik Reddy.
Present, sir.
Kirti.
Sir, 101 present, sir.
So Karthik Reddy is the group leader. Okay. (106) Anish Das. 107 Devrup Das. 108 Mayank Agarwal. 109 Riya Sudarshan. 110 Shreyans Shikhar. Who is there?
106.
106.
Sir, 107.
106. 107. Then who else?
109.
108.
108. 109 Riya.
Present.
110 Shikhar. So Shikhar is not there. Riya is the group leader. 111, 12, 13, 14, 15. Maitri Swarab.
Present.
You wrote a mail to me.
So that was proving the theorem which was there.
No, that is all right. So actually, why I am not proving the theorem? So we'll talk, because you see, this, you know, the x1, x2, x3, whatever you are taking the vectors, they are the extreme points. Okay, they are the extreme points. So let us say there are two extreme points. Okay, so it may happen. So see, these two are the feasible solution, and if these two are the basic feasible solution, we say that extreme point. So if there are two, you know, for either maximum or minimum, it may happen both are same value. So these two are the optimum solution. And if you have two optimum solution, we'll have infinitely many. Similarly, three. There are three extreme points: x1, x2, x3 vectors. Okay. So let us say out of three, maybe any two or all three, they are the extreme points and the optimum solution. So the convex combination will give infinitely many solution. Okay. So that it is coming from that theorem. When you prove the infinitely many solution, so this theorem is used. Okay. This theorem is used. Okay. So I am not proving, because if you prove, so you cannot cover so many things. Okay. 111 Maitri. 112 Umang Pandey. 113 Ayan Kumar. 114 Jatin Saini. Say 115 Tejasvi. 115. 115 is there? Not there. Anybody from this group?
Sir, 112 I am present, sir.
112. Then 113 Ayan Kumar. See, if you are present, tell me that you are present. So I am making, so 112, the group leader. Okay, right?
Okay.
116, 17, 18, 19, 20. 116 Aditi.
Sir, 120 is present.
Okay, 117 Nihal. 118 Abhay Kumar. 119 Sunita. 120 Anand Manoj Kumar.
Yes, sir. 120.
120 is there?
is present.
120 is there?
Yes, sir.
Okay.
Sir,
You are the
118 is there.
You are the group leader. Okay. 19 is there?
Yes.
19. 18 Abhay Kumar.
Yes, sir. Yes, sir.
17 Nihal Kumar.
Yes, sir. Yes, sir.
16 Aditi. Not there. Okay. Then 21, 22, 23, 24, 25. All are there? This you are second year student, no? Second year. Second year students?
Yes, sir.
So you are second year, and this subject, you know, this is very good for the mathematics, statistics, and for everybody. For this is a subject you are writing code and you are using. Okay. So there is a code, you know, that who has developed. His name is Narendra Karmakar in 1984. That paper I'll send to all the students. Okay. So actually that is not there in the syllabus, interior point method. Okay. but those are interested, you can write the code. And Narendra Karmakar is, he is from IIT Mumbai. So he completed his BTech in electrical engineering from IIT Mumbai, and he was JEE topper also. Okay, but he developed this code. Okay, this is a very alternative code for simplex method. Why? Because when a problem, a linear programming problem, has thousands of variables and thousands of constraints. So if you're writing code, sometimes to get this answer earlier, you are getting sometimes a week, sometimes a month. Okay, so this code, the interior point methods, getting solution very quickly. Okay, interior. Here we are searching all the extreme points, but the interior point say that we start with a middle point, interior point method point in the convex region, then you move to the extreme point. Okay, so this paper, I have that original paper. It is published in 84. Journal name is Combinatorica. So I will give around say 20 to 30 pages paper. So you should read, and since it is available, I have downloaded. So during my student life, so it was hard copy there, soft copy also I got it. So I will pass to everybody, not now, after some times. So you can go through. Okay, and since it is and about the Narendra Karmakar, you can search from the net. Okay, so you will get many things. Okay, about the interior point method, IPM. In short, write IPM. Okay, so you search it and get it ready. I will pass the paper to you after some time. Okay, not now. Then we have. See, we have a lot of computer science students. I'm sure you can spend your time and develop good code. Okay, so it will be useful to everybody. Okay, this is 121 Ashish Rekhani, 122 Buddha Mohan, 123 Krishna Venkat, 124 Giridhar, 125 Chandrasekhar. 125 the group leader, and who are there? Tell me. 121 is there. 122 is there. 123. 124. Very surprised you are not coming to the class. See, once you are not coming to the class, be sure you will suffer. 26. Surya Prakash.
26 present. 26 present.
26 present. Henceforward, you see, I will not give you the slide. So slide will be given. Those are attending the class. Okay. 126 Surya Prakash. 127. Pentam Sethi, 128, Prakhar Singh, 129, Priyanshu Dikshit, 130,
128
Swasat Naidu, 130 there.
Yes, sir, 130 present.
You are the group leader, okay. And who are there in this group? Tell me.
Sir, 129 also present.
Priyanshu Dikshit, right?
Yes, sir.
Okay. You know Professor Somesh Kumar, isn't it?
Yes, sir.
Okay. 128, Prakhar Singh.
Yes, sir, present.
Okay. 127. 127. 126, not there. Okay. 131. Shibam Raj.
126 present.
Shibam Raj is there. 132. Shreya Agarwal. Shreya.
Sir, 132 present.
Okay, 132 present. Shreya Agarwal. 133. Soni
Present,
Aditya.
Present, sir. 133 present, sir.
133. 134. Shubham Ghosh.
Sir, present, sir.
Okay. 135. Bachchan Siddharth.
Present.
Present. So you are the
Yes,
group
sir.
leader. Okay. See, today itself,
126
I have
present.
sent today. Yes, I have sent some file about the not today, yesterday. So about the simplex method, all simplex method. That is the simplex method for the condensed table, simplex method for the primal simplex method for the extended table. Then I have talked about the big M method, then the two-phase simplex method, then dual simplex method. Dual simplex method we will discuss. Okay, that we will discuss. It will take some time to discuss. And the revised simplex method slides I have sent earlier, isn't it? You got that file? Because when you write the code, this file is useful because all the steps are there stepwise. Earlier, so we are just applying some philosophy to solve the problem. Okay. First, I have taken a linear programming problem. All constants are one type. Then, when you are using artificial variables, what exactly you are doing, I discussed. Now, everything you have translated in terms of the algorithm, step by step. Okay. So you follow all these steps. Okay. So if you follow all the steps, okay, then your program, will be complete. The program sometimes infeasible, program sometimes unbounded, sometimes a linear programming problem has one solution, sometimes no solution, sometimes infinitely many solutions. Okay, so all the things should follow. Okay, so which problem, what is there in the primal, what is there in dual, what is the relationship, we'll discuss. Okay, so please wait for that. 135 up to 135 I have completed. One more page. 167 students are there. How many groups? If the group containing 5 students, how many? Tell me.
So 34.
34, 30, 33. Okay, 33 groups. 136. 136. Memory Harsha.
Present.
137. Siddharth Vishwakarma. 138. Aniket Kumar. 139. Ayush Kumar Divedi. 140. Pranab.
Yes, sir. 140 present.
140 you are there, no?
Yes, sir.
Sir, 138.
And tell me who are there? 136. 136.
Yes, sir. Present.
Harsh is there?
Yes, sir.
Then Siddharth? Not there. Aniket?
Yes, sir. Present.
Ayush Kumar?
Yes, sir.
Okay. Then 141, 42, 43, 44, 45.
Sir, 143 present.
Okay.
True.
41, Archit. Archit is there? Not there. 42, Jatin Gupta.
Yes, sir. 42 present.
43, Dhruv.
Sir. Yes, sir. Present, sir. 143.
44, Tanmay. Tanmay Mohanty.
Yes, sir. Present, sir. Tanmay Mohanty,
Okay.
144.
45, Abhijit Singh. Abhijit Singh. Not there. So Tanmay, you are the coordinator. Okay. So 146.
Sir, 146 present, sir.
146 Dhruv, Anubhav
Anubhav
Dhaw.
Dhar present, sir.
Anubhav Dhaw. 147 Aritra Mitra. 148
Present, sir.
Atish Jain. 149 Mohan Kishore. 150
Present, sir.
Swati.
Present, sir.
150 the group leader. Okay.
Present, sir.
Did you mark
149
146 present, sir?
140
Sir,
146.
147.
146 147 then
149.
149. Okay. 50 51 Gopal.
Yes, sir.
52 Gracie Sharma.
Grace Sharma present, sir. Grace Sharma present.
Your name is Grace Sharma.
Yes, sir. Grace Sharma present.
Okay. So 53 Joy Kumar Thakur. 54 Kushav Segal. 55 Manish. Who is there?
Present, sir.
Manish is there. Okay. And who else from the group? Gopal.
Yes, sir. 151 is present.
Grace Sharma is there. Joy Kumar. Kush. Kushaz. Not there. Okay. 56 Rohit Kumar Prajapati. You see all our computer students. 57 Rupak Priyadarshi.
Yes, sir, present. 57.
58 Raunak
Yes, sir,
Shah.
present.
59 Bhumika Agarwal.
Yes, sir. Yes, sir.
60 Saurav Padhi.
Yes, sir, present.
Okay. 160 the group leader. Okay. Bhumika Agarwal present. Raunak Shah.
Yes, sir.
Rupak.
Present, sir.
Yes, sir.
Rohit
present,
Kumar.
sir.
Yes, sir.
Rohit Kumar.
Yes, sir. Present.
Okay. Manish was already there. So 61,
Sir?
62, 63, 64, 65. There are 7 students. I will put in one group. Okay.
Sir, there is a
So
suggestion.
I'm telling Harsh Agarwal 167, 166 Dhruv. I will go from the 161 Aman Sharma. There? Aman Sharma, not there. 162 Saran Sharma.
Yes, sir. I am present.
Okay, Saran Sharma is there.
Sir, there is a suggestion.
See,
Since,
163 Anirudh. Anirudh?
Yes, sir.
There. 163. 164 Niharika Singh.
Present, sir.
Okay. 165 Anuranjan Sarkar. 165 Anuranjan Sarkar is there? Not there. 166 Dhruv. Not there. 167 Varsh Agarwal. Not there. 164 Niharika Singh.
Yes, sir.
Okay, you are the group leader because other 3 students are not there. 164. Okay. So,
Sir?
yeah.
162 is present, and I have a suggestion. Since 2 students will be extra, can you merge 161 and 162 with the previous group?
Okay, see,
it will be the same
I'm
department.
telling here, Aman Sharma, Saran Sharma. So 162. Okay. So I will make also another leader. So 162. Okay, right? 2 leaders are there.
Hey, sir, in case you can merge ourselves with the previous group, ending at 160. So
No, because it will be difficult for me to track.
No,
Multiple of
we
5.
are
Okay.
the last batch and 2
No,
students.
see here. See, I am telling. So this why I have done like this. I will tell you later because when I will grade you, I will tell you later. Okay. So see now many students will say, sir, you are selecting him, you are not selecting me. That. Okay. So I have taken, if suppose somebody is not doing duty, I can change the group leader. Okay. Tentatively, he is the group leader. Okay. So group leader means he has to interact and he has to when you write code, no, there will be some doubt. There will be some problem. Okay. So you have to ask me or you have to send a mail, I will reply. Don't write bigger mail. So 1 line, 2 line, I will reply. Okay. Because if you write 100 mail, I will not be able to reply. Okay. Right. See, the reason is you don't have so much time, no, and you are not coming to the class, and you are so many things. Still, many students are asking me, sir, send me the code. How many times I will send the code? Past 12 days. You know, you all were applying, you know, sir, take me, I want to learn OR, that. Past 12 days. So you are not coming, means you do not know. So something like that. So even mathematics students are not coming regularly. Okay. So at the end, those are present, but you have not, I have not marked your, attendance. So I will call you again if time permits. Okay. Right?
Sir,
So,
serial number 10.
Serial number?
10.
Okay.
Sir.
Otherwise, what you do, you send a mail. Okay, just this is your serial number. You send a mail. I will just mark. Okay, but I want to call you at the end. Okay, just like serially, I will call quickly. You can tell me if you are present, so I will mark. Okay.
All right.
Sir, 20 CS 3001 also.
So a lot of us are marked in the text in the chat box.
Tell me quickly. See, to take the attendance or to grouping. So I have taken 1 hour. Okay, this is not fair, but still I am taking because so I am allotting some work so that I will get input from you. Okay. So this first slide, many things just have skipped. So since I have told the dual simplex method we like to discuss. So I will say something about the duality. Okay, and this duality is very crucial. How it is crucial? In one line I will tell you. Say why it is crucial. You are giving me the answer for a problem. Okay. So to check whether this is the correct answer or not, I have to solve the problem. Yes or no? After solving, I will learn whether your answer is correct or not. But here, so using the duality theory, I can check whether your answer is correct or not. And it's very crucial. Crucial in the sense, let me come to the duality. So I will just talk about that. Okay. This slide in the very beginning I have given to everybody. Okay. I'll make it a little smaller. Okay. This is the problem. This is a linear programming problem. In this linear programming problem, what is there? There is a objective function maximization type. There are constraints. All are less than equal type. And here, whatever the BI is given, that BI is also non-negative. Okay. Generally, it is non-negative. All the right-hand side parameters are non-negative. And the decision variables, there are n number of decision variables. They are also non-negative. This is a linear programming problem. Okay. Linear programming problem. See, I will tell you, when there is one problem, only I have one problem, I will not name it whether it is problem 1 or problem 2. Say it is a problem. When there are two problems, I will name. This is the first problem, this is the second problem. Here, the first one, whatever I have stated, that is the primal program. Primal linear programming problem. Primal linear programming problem. With respect to the primal linear programming problem, we have dual linear programming problem. With respect to the primal, we have dual. Now you will ask me, sir, how you have derived the dual? There are some mathematics. So we'll discuss about that. How I have derived. So you know method of Lagrange multiplier. In the mathematics 1 you have learned method of Lagrange multiplier. Nowadays, due to the the COVID problem, some sections, some topics are covered, some sections, some topics are not covered. So generally that is used when you solve say maximization type problem, minimization type problem, mainly non-linear programming problem, not linear, mainly non-linear programming problem with some constraints. Generally, the constraints are equally typed. Whatever you have learned, the constraints are all equally typed. If it is not equally typed, we make it equal and solve. Okay. Have you heard the name method of Lagrange multiplier? Yes or no? Tell me. Yes. Have you heard the method of Lagrange multiplier? See, for example, I will tell you maximize x1 square. Okay. Maximize x1 square plus x2 square plus x3 square, let us say. So I have constant like say 2x1 plus 3x2 plus 4x3 equal to 10. Okay, like that. So if I am interested to solve what is the maximum value of the objective function and what is the value of the constants, maximize or minimize. Okay. So for example, I want to maximize, okay, maximize x into y. x into y, that is linear or non-linear? X into y, degrees to non-linear. And when we maximize x into y, it is given something like x plus y equal to 10. Okay, maximize x plus y equal to 10. What is the maximum value? And x and y are positive. What is the maximum value? X into y, we want to maximize x plus y equal to 10. So the maximum occurs at when they are equal. Okay.
25.
So it is a very small problem, and this you can also derive from the method of Lagrange multiplier. Okay. So if this is the primal, with respect to the primal, we have a dual program. See the primal dual. So you can say something like about this. If primal is, let us say, male, the dual is female. If the primal is female, the dual is male. Something like that. Okay. So something like this two pair of problem. This is one. This is another one. This two pair of problem. It has some relationship. Relationship in the sense. So this primal problem having variables x1, x2, x3, etc. They are called primal variables, and these constants are called primal constants, and this objective is called primal objective function. Okay, this is primal. With respect to the primal, we have the dual program. What is the dual program? With respect to the primal, we have a dual program D. What is the dual program? Dual program is like this. Minimize z dash equal to I varies from 1 to m bi into yi. See this yi, the dual variables. These are nothing but the Lagrange multipliers. We have to establish. So these are the Lagrange multipliers, and we want to minimize not z dash, some other objective function. I varies from 1 to m bi yi subject to I varies from 1 to m aij into yi greater than or equal to cj. J varies from 1, 2, 3 up to n, and all the yi are non-negative. This is the objective function. It is minimization type. This we are naming as dual objective function. The constants are dual variables and dual constants. The constants are called dual constants, and the variables are called dual variables. Now, primal problem, dual problem. We have two objective function, primal objective function, dual objective function. If primal is maximization type, dual is minimization type. If primal is minimization type, dual is maximization type. Okay, vice versa. Okay, and these primal constants are less than equal type. The dual constants are greater than equal type. The primal variables are xi or xj, j varies from 1 to n, and dual variables are, they are non-negative, I varies from 1 to n. This primal and dual, whatever you are getting, this is a symmetric problem. Symmetric. Symmetric means all the variables, primal variables are non-negative, all the dual variables are non-negative. This is symmetric. X non-negative, y non-negative. Primal objective function is maximization type, dual objective is minimization type. Primal constants are less than equal type, dual constants are greater than equal type. Okay, this clear? Now, if you ask me, sir, how we have derived? So we have to derive nearly 2 pages to conclude this. Okay, but please remember, if this is the primal, this is the dual. Okay, now I'm changing the problem. Okay, let me see the example. It is a small example. How many variables are there? How many variables are there?
2 variables.
This problem you have solved sometimes. How many variables are there? X1, X2?
2 variables, sir. 2
variables are there. So here we have 2 variables. There you will have 2 constants. And how many constants are there? There are 3 constants. These are primal constant x1 plus x2 less than equal to 100, x1 plus 2x2 less than equal to 110 and x1 plus 4x2 less than equal to 160. There are three constants. So in the dual program, there will be three variables. If it is maximization type, the dual program will be minimization type. And there are three constants, there will be three variables. And there are two variables, there will be two constants. And these constants are here less than equal type, there will be greater than equal type. This is maximization type. Okay, this is maximization type. And our dual program, see the dual program, maximize z dash 100 y1 plus 110 y2 plus 160 y3, y1 plus y2 plus y3 greater than equal to 1, y1 plus 2y2 plus 4y3 greater than equal to 3, y1, y2, y3 greater than equal to 0. Okay, the primal and dual. Now, so this primal problem is given. Okay, so if it is asked, solve it. How do solve this problem? Primal, how do solve this problem? Any answer? Which method will apply? Graphical, excluding the graphical method. Which method will apply to solve the problem? Tell me.
Simplex method.
Yes. Moitri. Which method will apply to solve the problem?
Yes, sir, we'll solve it with simplex method.
Simplex method. And that simplex method now we'll name primal simplex method. That method will name as primal simplex method. Okay. Primal simplex method. You see here, say earlier we are, let us say we have one weapon to cut the vegetable. And with that weapon we are also sometimes cutting the fruit also. Because if you have two different weapons, one is for the cutting vegetable, another is for the fruits. Okay, two different. So then what will happen? So we'll name it. First one, second one. Okay, or typically you'll write. For example, here, see, if you are cutting, see, something like potato or tomato, is small knife is all right. But fruit like jackfruit, in the same knife you cannot cut. Okay, and a vegetable like pumpkin, you need a bigger one. Okay, so they're different. So here, similarly, different problem, different technique you have to apply. And if you want to apply the same technique, we have to change it. We have to convert to standard form. Okay, this problem. See, here I want to tell if this is the primal, the dual is like this. Dual is like this. Now, for the dual problem, which method will apply to solve? Which method will apply to solve? Who can say? This primal dual.
Big M.
Sir, big M.
Big M. Tell me other methods.
Sir, two-phase simplex.
Two-phase. Then what else? Here also, I have not discussed. We can also apply dual simplex method because dual, no? We can also apply dual simplex method. Two-phase or big M and dual simplex method. Now you remember, and here some interesting point. What is the interesting point? Maximum value of Z equal to minimum value of Z dash. What is the reason? Reason is both the problems are feasible and has optimal solution. So once it is feasible and both have optimal solution, maximum value of Z equal to minimum value of Z dash. Now, for example, this primal one is not given. This is not given, only dual one. So you have to solve it. Okay. Now you will apply big M method, two-phase simplex method, dual simplex, what I told. One clever student, what you will do, you will simply take this problem and find the dual. See, if this is primal, the example one, this is the primal and this is the dual. if I'm naming primal will be dual. If the dual is the primal, then the primal will be dual. Vice versa. If this is the primal, that is the dual, and if this is the primal, then that is the dual. Okay, right? Now we will take this problem, dual problem, this last second problem, and find the dual. Dual will be primal. We can solve the first one. Solving for x, how can you find y? There are some technique we'll discuss. Solving for x, solving for y, you can find x. Similarly, solving for x, you can find y. Okay, these two are related. Okay, so this you will learn from the dual simplex method, and some theorems are there. We'll discuss about that. Now see here the second problem. Second problem. If this is the primal, what is the difference between example 1 and example 2? What is the difference between example 1 and example 2? See, same example I have taken, only the last two constraints are equally type. Last two constraints are equally type. Other things are same. What will happen? Please remember, whenever we will find a equality constraints, with respect to the equality constraints, there is a dual variable. That dual variable is a free dual variable. I am coming again to this problem. First constraint, second constraint, third constraint. With respect to three different constraints, with respect to first constraints, we have a dual variable y1. With respect to second constraints, we have a dual variable y2. With respect to third constraints, we have a dual variable y3. So in this example 1, all are non-negative. In the example 2, with respect to this problem, the dual is same, but this y2 and y3 are free. These two variables are free. Free means these two variables can be positive, can be negative, can be zero also. Free variable, it can take any value. Okay, so whatever it is given, suppose say y1, y2, y3 non-negative. This y1, y2, y3 non-negative. This non-negative condition, see these variables, they are non-negative. Say what you can say, y1, y2, y3 are continuous variable or discrete variable? What you can say? Continuous or discrete?
Continuous.
Continuous. If, for example, y1, y2, y3, I am naming they are binary 0, 1. They are discrete. y1, y2, y3, they are integer 1, 2, 3, 4, etc. 0 including 0. They are integers. Non-negative integer, sometimes binary. So these are continuous. So when we find that these variables are integer, so we'll discuss about the integer programming. Okay. So we'll come to that after completion of the dual simplex method, integer programming. Okay. So here y1, y2, y3 are continuous, and here also x1, x2 are also continuous. Now in the example 2, x1, x2 are continuous, and here y1, y2, y3. y1 is non-negative, y2, y3 they can be 0, positive, negative. They are also continuous. Okay, it's complete. Now I am coming to third example. See here. Third example. Earlier you see we have taken a problem. All the constants are less than equal type. Auxiliary function was maximization type. Here I am taking a problem. Auxiliary function is minimization type. Constants are all greater than equal type. Now which method will apply? Which method will apply to solve example 3? Tell me. Big M method, two-phase simplex method, and
dual simplex.
Dual simplex also. Dual simplex I have not discussed. We will discuss dual simplex also. This is, please remember, big M method and two-phase simplex method, right? Big M and two-phase. So this is minimization type. So with respect to this problem, we have a maximization type of auxiliary function. With respect to this problem, we have there are three different constants. We'll have two different variables, dual variables, y1, y2, and these two constants are less than equal type. This is the problem. Maximization of z dash 100 y1, 110 y2, 160 y3, and y1, y2, y3 they are less than equal to 1. y1, 2y2, and 4y3 less than equal to 3. This. Which method will apply this problem, the dual problem? So, with respect to this is the primal. If example 3 is the primal, then it is the dual. So I have already told, if example 1 is the primal, if this is the primal, then this is the dual. Okay, vice versa. So example 3, if this is the primal and this is the dual. Okay, these slides already I have given you much early. You got the slide? You got the slide or not?
Yes, sir.
See, whenever you are getting the slide, at least carefully spend some time for the slide. Okay, because you are not asking question. You are sitting simply, there is no reaction, nothing. And don't, if you do like this, don't expect that you will get, you may pass it. There is no problem. So the subject is very interesting, but getting good grade, you have to spend good amount of time and you have to be very intelligent. Okay, and everywhere some tricks are there. Everywhere some tricks are there. Okay, and we are solving only equation, nothing else. Still, lot of tricks are there. You will learn. Okay, this. Now come to this problem. The primal is what? Minimization type objective function, and these three constants, 2 are greater than equal type, and third is equally type. What will happen? The dual will be maximization type. There are three constants. There will be three constants, two variables. There will be three variables, three dual variables, and how many constants? How many constants? There will be two constants. So with respect to third constants, the third dual variables is free. See here. So that is maximization type problem. y1, y2, y3 less than equal to 1, and y1, y2 less than equal to 3, less than equal to 3 here. y1 plus 2y2 plus 4y3 less than equal to 3. y1, y2 0, and y3 is 3. Now I will tell you here in this problem, can you solve this linear programming problem? The dual one, what I have mentioned. If you can solve, which method will you apply? Which method will you apply?
So simplex.
Simplex method. But simplex method say all the variable has to be non-negative. But here one variable is free. What will do? What will do? See, simplex method is applicable when y1, y2, y3 all are non-negative, but third variable is non-negative. Free. Free means, so it can be 0, it can be positive, it can be negative. Once it is becoming negative, so this will not give basic feasible solution. It is a basic solution, all right, but it cannot be basic feasible. For linear programming, basic feasible means all the variable has to be non-negative. So here is the trick. Trick is like this. Let y3 equal to y3 dash minus y3 double dash. Say y3 equal to y3 dash minus y3 double dash. And y3 dash and y3 double dash, these two variables are extra variables. They are non-negative. Or you can say, for example, our y3 equal to y4 minus y5. So replace y3 by y4 minus y5. So once you replace in this manner and you mention y3, y4 and y5, they are non-negative. The difference of 2. This difference, if both are equal, it is 0. If first one is more than second, it is positive. If first one is less than Second, it is negative. So you can replace everywhere y3 by y4 minus y5. As a result,
So,
how many variables will be there? Yes.
4 variables. And so the new variables are almost like adding an artificial variable and a surplus
That
variable.
artificial we have not reached. That artificial slab we have not reached. Now we are what we are doing. We are transforming. I told any problem you can transform to standard form. So I am making it a standard form. To make standard form, make y3 equal to y4 minus y5. As a result, it will be 100 y1 plus 110 y2. We want to maximize z dash plus 160 y3. This third term will be 160 y4 minus 160 y5. y3 is not there. In the first constraint, y1 plus y2 plus y3 less than or equal to 1. So it will be y1 plus y3 plus y4 minus y5 less than or equal to 1. In the second constraint, y1 plus 2y2 plus 4y4 minus 4y5 less than or equal to 3. So in our problem, we have instead of 3 variables, we have now 4 variables. So we will find the value, the problem, if it is feasible, has solution, we will find the value. After finding the value of y4 and y5, we can get y3 equal to y4 minus y5. Okay. So that is the rule. Okay. So if all are free, instead of 1 variable, you can make a difference of 2 variables. Okay. y1, y2, y3, if all are free, so 3 variable will become 6 variable. Here only 1 variable is free. So first 2 we are keeping as it is. Instead of y3, we are using y3 equal to y4 minus y5. So there will be 4 variables. Okay, this up. There is no problem. Now, see, this is another example. The objective function is maximization type. The constants are equally type. Which method will apply to solve the problem? Which method? One method is basic feasible solution method. Okay. How to solve? These two are equally type. You set x3 equal to 0, find solution. If it has solution, you can find solution. Then whatever solution you are finding, it may be basic feasible, it may not be basic feasible. Then second one, x2 0, find solution. Third one, x1 0, find solution. There are 3 different cases. Maximum you will find 3 basic feasible solution. So among 3, all may be same. Maybe 2 are same. Maybe 1 is okay different, something like which is giving maximum solution. So using the basic feasible solution method, you can find solution. But generally we are using simplex. If you are using simplex method, which method is suitable to this problem? Example 5. Which method? Please tell me. Which method? Are you able to hear? Big M method, yes or no? Hello?
Yes, sir.
Two-phase simplex method, yes or no? Two-phase simplex method also, right? Because big M method, two-phase simplex method, we have to introduce artificial variables, and that artificial variables we have to remove by some mean. Okay. So, but we are not solving the problem. We are finding the dual program. The dual program you can see here. These two are equally type constants. For the equally type constants, there are 2 dual variables. Okay. And these 2 dual variables will be free. See here, this is the problem. Now, which method will apply to solve the problem? Before applying the method, we have to transform. How to transform? Change y1 equal to y3 minus y4. y2 equal to y5 minus y6, let us say. So this y1, y2, we will express in terms of 4 variables, y3, y4, y5, y6, where all the 4 variables are non-negative. y1 equal to y3 minus y4, let us say. y2 equal to y5 minus any two you can select, okay? Then there will be 4 variables. How many constants? How many constants? 1, 2, 3, 4. 3 only, not 4. There will be 3 constants, 4 variables. The problem is minimization time. How to solve? Which method will apply? Which method will apply?
The big M method.
Big M method again. Two-phase simplex method. After finding the solution, you will get back the original solution y1, y2. y1 equal to y3 minus y4. y2 equal to y4 minus y5. Where y3, y4, y5, y6 all are non-negative. Okay, that's all. Now I am stating some theorem. This theorem is very crucial to test the problem, the linear programming problem, LPP prime null. P is consistent, has a maximum value. That value is a MP. If and only if it's dual. Dual D is consistent, has a minimum value MD. Moreover, maximum value equal to the minimum value. So MP equal to MD. Either this hold or sometimes some problem you will see MP is less than equal to MD. Okay, I will tell you about that. See here, if X satisfies the constraints of the primal program P, Y satisfies the constraints of the dual program D, in generally this left hand side, left hand side, whatever is there, that is the minimum value of the objective function. And right hand side, whatever is there, that is the maximum value of the objective function. The minimum value of the objective function is greater than equal to maximum value of the, this is about the dual objective function, left hand side. The right hand side say about the primal objective function. This is greater than this. This theorem say something about weak duality. The first theorem say something about the strong duality. MP equal to MD. Both are equal. And here the right hand side is MP. Left hand side is MD. MD generally MD is greater than equal to MP because this is weak and this greater than equal to this constraint is a, this is a bigger set and the equality is a smaller set. So this is the smaller set. The theorem 1 say strong duality theorem and this is a weak duality theorem. And this result say equality holds if and only if. The theorem 1 holds if and only if either xj equal to 0 or summation over I varies from 1 to m aij yi equal to cj. Either this equal to 0 or this is equal to, either means maybe xj 0 or summation over I varies from 1 to m aij yj equal to yi equal to yj. Both may be true also because it is or means both. Okay, to solve this problem, and similarly yi equal to 0 or j varies from 1 to n aij xj equal to bi, this is 0. To solve this problem we may use dual simplex method. To solve this problem, the dual problem, we may use dual simplex method. Okay, so some discrete models. I have told discrete model means this j, the variable xj, for example, takes discrete value, integral value. This we will discuss later in the integer programming. Okay, and to solve the discrete problem, we use Gomery's cutting plane method or branch and bound method, or that is the additive algorithm. Okay, we'll discuss. And the reference you see. So the first book is Optimization Theory and Application by S.S. Rao. the engineering optimization by S.S. Rao. And there is also, linear programming SI Gauss. Okay. Also you can use this. Now I will just, whatever you discuss in this problem, the theorem 1 and theorem 2, we like to demonstrate with some example. Okay. Then I'll come to the theorem. This I have already given. No need of giving the same slide to you. Okay. Before proving this theorem, I like to discuss the numerical example a little, so that you will be able to realize this is the problem. Okay. I have changed the problem slightly. It was something like 100, 110, 160. I have removed 1 0. Okay. So that you can quickly guess. This example 1. So I'm naming it is a type 1 problem. It is a symmetric problem because various types problems are there. A type 1, just I'm naming this type 1 problem. So with respect to type 1, this is the primal linear programming problem. I'm naming this problem as primal. How many variables are there? There are 2 variables. How many constants are there? There are 3 constants. Okay. So let us say we're applying the simplex method and we are finding solution. Simplex method I am applying and finding solution. Okay. Already we have got solution earlier. Okay, if you apply, you will also get the same solution. So please verify, and this is solution. X1 equal to 6, X2 equal to 2.5, that is 5 by 2, and the maximum value equal to 13.5, 27 by 2. Okay. So if you substitute in the first constraint, what is happening? X1 equal to 6, X2 equal to 2.5. The first constraint is fulfilled or not? Fulfilled or not? Hello? Whether it is fulfilled, satisfying the requirement, X1 plus X2 less than equal to 10? Yes, because sum is becoming 8.5, 8.5 less than strictly less than 10, not becoming equal to. Now, second one, X1 plus 2X2 less than equal to 11. Now, if you substitute X1 6, X2 5 by 2, 2X2 5, 6 plus 5 11. This is becoming equal to type. Sum of these 2 terms equal to 11. Yes or no? Are you checking? Hello? The second one complete. Third one, X1 equal to 6 and X2 equal to 2.5. So X1 plus 4X2, the sum equal to 16. So what we observe, first one is not fulfilling the requirement, only satisfying. So X1 plus 2X2 less than equal to 11, it is fulfilled. X1 plus 4X2 less than equal to 16, it is fulfilled. So we got the solution. This solution certainly it is feasible, but how to guarantee that it is optimal? So we have to test using duality theory. Okay. Now this is the primal. So primal is complete. Now I'm talking the dual. Dual is this. So for this dual, we want to minimize Z equal to 10 Y1, 11 Y2, 16 Y3, subject to Y1 plus Y2 plus Y3 greater than equal to 1, Y1 plus 2 Y2 plus 4 Y3 greater than equal to 3. Okay. So the solution is given. Don't use the solution. So we have to verify. Without solving, we have to verify. This is the problem. Now, if you are solving the problem, which method will apply? Which method? Who can say?
Big
Which
M.
method will apply?
Big M method.
Big M, two phase. Okay. So we are not solving. And since we got some solution, this solution, we have to use this solution to verify. And this solution, whatever we have got, that is optimal. Whatever is written, it is optimal. Now next question is see. Please check x1 equal to 6, x2 equal to 2.5 is a feasible solution. Feasible. Please check again x1 equal to 6, x2 equal to 2.5 is an optimal solution. Using duality theory, it is an optimal solution. I am adding one more line. I am adding one more line in this problem. Say x1 equal to 0, x2 equal to 4. The first constant is fulfilled. x1 0, x2 equal to 4. Fulfilled? Yes or no?
Yes, sir.
Yes, sir.
Second constant is fulfilled. x1 0, x2 4. Fulfilled? Yes?
Yes, sir.
Third constant is fulfilled.
Yes, sir.
Yes,
Yes,
sir.
sir.
And it's satisfied also.
Satisfied? But see, we can use also z equal to x1 plus 3x2. 0 plus 3 into 4. How much? 12. Earlier you got 13.5, it is 12. So these two are solution. So I cannot jump to conclude that this is the optimal solution. There may be some other solution also. We don't know. The feasible set is, feasible set is huge. So many points are there. See, only optimal solution occurs at the extreme point only, nowhere else. Okay, in the feasible region. So if it is bounded, it has finite number of extreme points. Solution, the optimal solution occurs at the extreme point only. Okay, so we got two extreme points. I'm checking. There may be some other extreme point also. Okay, so we want to check. So these two will check and conclude. Now see here how I'm checking. This is the problem. Primal, dual. If this is the primal, can you formulate dual in this manner? Yes or no? They are symmetric. x1 is non-negative, x1, x2 non-negative, y1, y2, y3 non-negative, symmetric. With respect to the symmetric, so we are checking. So to check, we have to have three constraints with respect to three constraints primal, three constraints primal, three dual variables. Primal, three constraints, dual, three dual variables. And similarly, dual, two constraints, primal, two dual variables. Okay. So the complementary pair will have like this: x1 plus x2 minus 10 into y1, their product equal to 0. Second one, x1 plus 2x2 minus 11 into y2 equal to 0. Third one, x1 plus 4x2 minus 16 into y3 equal to 0. This will be fulfilled. If it is optimal, okay, it is fulfilled. And if it is a feasible solution, also it is fulfilled. But if it is optimal, the maximum and minimum has to be same. Again, the last two, y1 plus y2 plus y3 minus 1 into x1 equal to 0. y1 plus 2y2 plus 4y3 minus 3 into x2 equal to 0. I am checking here. See. So y1, y2, y3 is not given to us. We want to find out. So x1 plus x2 minus 10. How much it is? x1 plus x2 minus 10. x1 was 6. We have got x2 is 2.5. x1 plus x2 equal to how much? 8.5 minus 10. So x1 plus x2 is 8.5 minus 10. That is coming as minus 1.5 into y1 equal to 0. What it concludes? What it concludes? What it concludes? y1 0? Yes or no? So these two product minus 1.5 into y1 equal to 0. Since 1.5 is not 0, y1 has to be 0. So we got y1 equal to 0. Please remember, we got y1 equal to 0. Now, last two I'm using, last two. X1 is 6, not 0. X2, 2.5, not 0. If X1, X2 are not 0, you can write Y1 plus Y2 plus Y3 minus 1 equal to 0. Y1 plus Y2 plus Y3 minus 1 equal to 0. Earlier you have got Y1 equal to 0. So Y2 plus Y3 equal to 0. You can see here. Y1 0, Y2 plus Y3 equal to 1. Now in the second one, X2 is 0. Since X2 is 0, Y1 plus 2Y2 plus 4Y3 minus 3 equal to 0. Y1 0. If Y1 equal to 0, we have two equations. Y1 plus Y2 plus Y3 equal to 1. Then 2Y2 plus 4Y3 equal to 3. After solving these two equations, we got Y2 equal to Y3 equal to half. So what you have got? Y2 equal to half, Y3 equal to half, and Y1 equal to 0. Now come to this problem. Y1 0, Y2 1, Y3 1. What is the sum? 11 by 2 plus 16 by 2 together 27 by 2. That is 13.5. That is the minimum value. And maximum value is also 13.5. Maximum value 13.5. So it is satisfying minimum value of Z dash equal to maximum value of Z. So it is an optimum solution. Now, in case you are taking 0 and 4, 0 and 4, is it satisfying the constraints? Is it satisfying the constraints? Yes, satisfying. So x1 plus 4x2 less than or equal to 16. So what is happening to this? First two are 0, means y1 has to be 0, y2 has to be 0, y3 is non-zero. So with respect to this, what is the value of z? Is becoming 12. Z is becoming 12. Okay, x1 plus 3 into 4 becoming 12. Z is becoming 12. Now here, as you observe, in this problem, we have already taken y1 0, y2 0. So y3 greater than or equal to 1. Okay. Then y1 0, y2 0. 4y3 greater than or equal to 3. So y3 greater than or equal to 3 by 4. y3 greater than or equal to 1. y3 greater than or equal to 3 by 4. So what is the value of y? Both will be fulfilled, no? y3 greater than or equal to 1. Then say here 4y3 greater than or equal to 3. y3 greater than or equal to 3 by 4. 3 by 4 and 1. What is the intersection? y3 is non-zero. Tell me how much? How much you got here? Whether y3 equal to 1 or 3 by 4. Are you able to hear?
1, sir, 1.
1. If y3 is 1, y1, y2 0, what is the value of small z?
16.
16. Earlier you got how much? 12. Now you got 16. So which one is more? This minimum value of the dual objective function is always greater than or equal to. Here it is becoming strictly greater. Earlier it was equal to. Equal to means it is a strong duality theorem, means that is the optimal solution. Here this is a weak duality theorem, that is the feasible solution. Greater than, strictly greater than, the 16 is strictly greater than 12. So this solution, whatever it is given here, this is the optimal solution. But once you set x1 equal to 0, x2 equal to 4 with respect to 0 and 4, we are getting solution like 0, 0, 1. So that is becoming a feasible solution. 0, 0, 1 is a feasible solution or not? Check. Yes, it is fulfilled. And this also fulfilled. 4 is greater than 3. So the weak duality and strong duality, I have given an example. This feasible solution, okay, feasible solution can be also optimal. Okay, but if it is not becoming optimal, this will satisfy the weak duality theorem. If it is becoming optimal, this will satisfy the strong duality theorem. Okay, right. Now I'm coming to this theorem, what we are going to, the result, what we are going to establish. It will take one complete class. So I have considered, this is today's slide, okay. This is the first problem. See here, we have talked about this problem. Okay, so the first problem is like this. So instead of z, I have changed to a function f, because that function earlier it was linear. Now I'm putting some nonlinear terms. Okay, why nonlinear? I will tell you. This is the model 1. Can you see the model? So all my models are maximization type. Okay, all my models are maximization type. Okay, this is linear programming model 1. Okay, so model 1. Now I'm coming to model 2. What is the difference? Model 1 and model 2. What is the difference? Okay, see here. The model 1, the constants are all less than equal type. Model 2, constants are all equally type. Model 1, variables are non-negative. Model 2, variables are also non-negative. What is the difference of these two models, 1 and 2? Who can say? There is any difference? This constant there is in equation, here it is equation, model 2. Now coming to the model 3. Model 3 and model 1, if you compare model 3 and model 1, this is model 1, all the variables are non-negative. Model 3, same, but here the variables are free. The variables are free. There is some difference. The free means, so there are n variables. If you want to make it restricted, so you have to use the xj equal to difference of two variables non-negative, xj equal to xj dash minus xj double dash. So instead of n variable, there will be 2n number of variables. Okay, it is hidden. So xj is free. So this is the difference. Now fourth model. Fourth model, the constants are equally type and variables are also free. So these four models we like to derive. Okay. So derive mathematically. Okay. There are four models. We assume all Aij, Bj and Cj are deterministic. They are real number and objective function and constants are linear. We may apply the following methods to find the optimal solution. One is primal simplex method, then big M method, two-phase simplex method, dual simplex method, revised simplex method, and the last one is interior point method. Okay, these all the method 1 to 5, all the methods are developed. So between say 40 to, I can say 40 to 60. All the methods are developed. Okay, so the last method was developed in 1984. Okay, this is a very superior method. Okay, but this problem, the last problem, cannot be solved in the classroom quickly because you have to have some numeric computation. Okay, so about this, all the problems 1 to 5 you can solve in the classroom. So for smaller or bigger, so certainly you can use, but the last one cannot be used. So it is becoming lengthier due to the numerical computation. Okay, this. Now see the problem mathematically how it is. We are going to derive the primal and the dual program. See here, objective function is in the matrix notation. You can write objective function f equal to C transpose x, subject to x less than or equal to b. X is non-negative. The C is a column vector. The elements are C1, C2, Cn. Column vector. X is a column vector. The elements are x1, x2, xn. And here it is given x non-negative. Non-negative means x1, x2 up to xn, they are non-negative. And the B vector, okay, so of size m here, B1, B2, Bm. The A matrix is a matrix of size m by n. There are m number of rows and n number of column. The elements are Aij. Okay, this. So A is defined, small b is defined, C is defined, X is defined. Okay, this. In the linear programming problem, we use capital B. We use capital B. What is capital B here instead of small b? Who can say? What? Yes. What is capital B? See, capital B is a square matrix. This A may be square, may not be square. May be square, may not be square. But capital B is a square matrix. This is called basis matrix. Generally, in the linear programming problem, our basis matrix is non-singular. If it is singular, we leave that. No solution is possible. That is over. So generally, basis matrix is a square matrix. It is non-singular. So B of size m by m, basis matrix. So in the basis matrix, we are using product form of inverse. You know it, okay? So when you find basic feasible solution also, we are finding the inversion, okay? To find the solution, okay? This. Now, this is the, in the matrix notation you can write in this manner. And if you expand it, so you can write in this manner. Our primal P will be maximize f, summation over j varies from 1 to n, Cj xj. Summation over j varies from 1 to n, aj xj less than or equal to bi, and xj non-negative. This. Now there is no nonlinear terms. Okay. So in this problem, if you are using simplex method, which simplex method will you apply? Which simplex method will you apply? Yes.
Primal simplex.
Primal simplex. Let us assume the bi is non-negative. Nothing is mentioned here. I am assuming bi is non-negative. Non-negative. If it is non-negative, for example, in the problem, first problem, I have taken 10, 11, 16, b1, b2, b3. So if you are using simplex method, primal simplex method, we have to introduce slug variable. Okay. We have to introduce slug variable. Yes or no?
Yes, sir.
Slug variable. Generally, slug variables are non-negative. Non-negative. Okay. Generally, slug variables are non-negative. Okay. I have to mention it is non-negative. But see here, what I are going to do. So, if this is the primal, we write in this form. And the dual is like this. In matrix form, the dual is like this. Minimize f dash, that is equal to b transpose into y, a transpose into y greater than or equal to c. Y is non-negative. Okay. And the y1, y2, im, these are the components. Okay. Now, in the expanded form, this is the dual. Now, there is a question. How do you find the dual of a LPP? The answer is, we'll use Lagrange multiplier method to establish the dual. The details are given below. See, the linear programming problem, generally we solve maximization type problem. For the nonlinear programming problem, generally we always solve minimization type and we convert to always minimization type. Okay, what is the reason I will tell you. So please remember, if it is given a minimization type LPP, we multiply minus sign to make maximization type. Here similarly, if we are using the nonlinear programming concept, so always transform the problem to minimization type. This is maximization type problem, change it to minimization type. You can write in this form, yes or no? Now, this is the constraints. Okay, these constants are like this. So it is given add a slack variable. The slack variables we write in this form. SI square greater than or equal to 0. SI square greater than or equal to 0. See, if I'm saying SI is non-negative, I have to write down SI is non-negative. But here, if I'm writing SI is a real number, SI square is always non-negative. No need of telling anything. Yes or no?
Yes, sir.
We'll write SI square greater than or equal to 0. Once I'm saying what type, so the SI square is a continuous variable or discrete variable here. What is our assumption? Continuous variable. Okay. Now see how we are writing. Summation over j varies from 1 to n, aij xj. It was less than type. So add a variable SI square. This is non-negative. Add it. Minus bi equal to 0. Equation 2 is fulfilled or not? Yes or no? Okay.
Yes, sir.
Now, see here, our xj is greater than or equal to 0. If xj greater than or equal to 0, multiply minus sign, minus xj equal to less than or equal to 0. True or not? For this type of equation, minus xj plus tj square. Again, I am adding some slack variable type, not saying anything. So this tj square is a such slack variable because tj square equal to 0. So this tj square is non-negative. So this completes. Now our Lagrange multiplier function we are formulating. Our formulation is like this. So I will continue from this line tomorrow. Is it all right? Okay, this. So this will help us to derive dual. This will help to derive the dual. Okay, this. So after completion of the tomorrow class, I will pass this slide to you. Okay, right? Okay, thank you. I will stop here. Time is up.
Thank you, sir. I was unable to speak, so when you took attendance, can you please mark me present?